Yeah, warm good morning class. In our previous video we have seen about what is ion carbon diagram, why we have to learn this ion carbon diagram. Okay, so in the previous video we have split this whole ion carbon diagram into small pieces, and we have learned a small glimpses. We have seen about major phases of the diagram. So now we are going to see. Now we are going to see carbon content. We can easily remember this carbon content. I'll explain it in a way where you can easily have it in mind. So okay. So now take this part. This is the part which is very much small things. Okay. It is first is 0.10, next is 0.50, just is okay. Next is 0.10, 0.18, and 0.50. Okay. Now we can classify this percentage of carbon. That means sorry, weight percentage of carbon. Okay, now this 0.10 up to 10 it is called as child age, right? So then when we reach 18 it is teenage, and when we go to 50 it is old age. So keep this as a segment. So it is 0.10, keep it as 10. 0.18 it is keep it as 18, and 0.50 keep it as 50. But remember you have to add a 0 point at the front, right? So this is the way you can remember it. Okay, so here you can see up to here you can see the complete delta ion part, right? You can see the complete delta ion part here. So as this loops, as I already indicated, the loop which is touching the loop which is empty here, as in the previous way we can see these are the loops which is seen. Okay, and I have said that in the inside the loop we can see the formation of two phases. So these are the major phases where we have seen in the single manner, and in the other phases, other loops where you can see here it is formation of two phases. The loop which is touching the two major phases are seen inside this loop, right? So the same way, okay, now we are going to see the next one. Take it as here, this you keep it in mind. Okay, from here you can see it is 0.8, 2 and 4.3 and 6.67, right? Okay, we'll keep it like this. It is 8 o'clock. We are getting ready for college. We are going to college. We are going to work by 8 o'clock. Okay, 2 o'clock we will finish the lunch. 4:30 we are leaving the college, and 6:30 we are reaching the home. Okay, keep it like this. Okay, it is 0.8, 2, 4.3 and 6.67. Okay, the wonders here, we cannot add the carbon to the ion only up to 6.67. We can add only up to 6.67. Means that if we add beyond 6.67, we can there will be the carbon and ion will not collide together or mix together. It will be stand separately, and we can say up to this. We keep it in mind, up to 2.2% of carbon. It is completely 2% weight percentage of carbon. It is completely steel part. Okay, it is completely on steel part. So when up to from 2.1% up to the 6.6%, it is cast iron. It is cast iron. So we can see this ion carbon phase diagram deals both steel and cast iron. So up to 2% of if you are adding carbon from 0.008% up to 2%, it is known as steel. If you are adding from 2.1% to 6.5%, it is cast iron. But practically we are speaking, we cannot go up to 6.67. We will finish it up to 6 itself. Okay, so before 0.008 we cannot add carbon. So that is the purest form of iron. Okay, purest form of iron. So now the next thing is that next important thing in this ion carbon phase diagram is individual apart from this 5 individual phases, as we already discussed. This is alpha ferrite is just BCC, that is body centered cubic crystal structure. This is austenite, and this is the ferrite, and we have another ferrite is known as this is from this is the alpha ferrite, and this is the delta ferrite. Both are looking like twins, right? Both are looking like twins. But only difference between the both is alpha ferrite is can be attained in the room temperature, but delta ferrite only occurs at the high temperature part. This is the cementite. It is an intermetallic compound. Okay, which is seen on the top, which is seen on the right corner as in this as we are seeing the Fe₃C, that is 6.61% of carbon, and of course it is the liquid. After 5,000 degrees Celsius, it is the iron is completely melted out, and it is seen in the liquid, as the liquid part, right? So first one, why this iron and carbon are mixing together means it should form a combined solid solution. As here you can see, this is an intermetallic, means iron carbon is intermetallic, where this here you can see there are two types of solid solution, as we discussed long back ago, we can see there are two types of solid solution. One is substitution solid solution, next one is interstitial solid solution. In substitution solid solution, you can see the one atom is removed and another atom is placed. But in an interstitial solid solution, you can see one atom is placed between the two atoms, like here. Like here it is placed. So as like this iron carbon phase diagram, you can in iron carbon alloys, you can see this carbon atom forms the interstitial space between the ferrous atom. As an added information, only there are 5 elements: boron, carbon, nitrogen, oxygen, nitrogen will form the interstitial solid solution in total periodic table, right? We'll see the rest of the rest of the pieces of this iron carbon diagram in the next video. Thank you.